All right, for our first question that we're going to do here, first thing that we need to sort out is which one of the gas laws that we're going to use. And our pressure is changing for one, and the volume actually also is changing. So if we're changing pressure, volume, or temperature, then we have to use the combined gas law. The combined gas law is this one: P1 times V1 times T2 is equal to P2 times V2 times T1. So once we have that in hand, we just need to go into the problem and find all the pieces that we need. So I'm going to go into the problem. A sample of gas occupies, and it occupies this volume, V1. It's important that I associate this volume with this temperature. And so the temperature is 25 degrees C. The temperature is the only one that has a specific unit that it must be. This temperature must be in Kelvin. So I'm going to add 273.15, and that makes my T1 here be 298.15 Kelvin. My pressure can be in any good pressure unit, and so my P1 here is 760 millimeters of mercury. Then we're asked what volume, so that's going to be the volume that it changes to, V2. The temperature is the same temperature, and we could approach this a couple of ways. We can say that T1 equals T2, or we can put them both in the equation and say that they're both 298.15. Either one will do exactly the same thing, so we'll see what we do when we get to that. And then finally, this is the P2. This is the second pressure that we're dealing with. So let's fill in our little table here. The first pressure is 760 millimeters of mercury. The first volume, I'm going to go ahead and make that just 1,400 milliliters. My T1, the temperature is the same, so let's just say T1 equals T2 and T2 equals T1. We'll just drop those out of the equation when we do the calculation. My P2 is 380 millimeters of mercury, and my V2 is my unknown quantity. So now we're going to solve for V2, and so we'll divide both sides by everything that's not V2 on this side, and that gives me that V2 is equal to P1 V1 T2 over P2 T1. As we just said, the temperatures can fall out, and you can see either I could set these equal and then cancel, or I could put 298.15 here and 298.15 there, and it would cancel. So either way, that's going to cancel out. And so finally, my P1 is 760 millimeters of mercury. My V1 is 1,400 milliliters. My P2 is 380 millimeters of mercury. And so my pressure units cancel as they need to, and at the end of the day, they leave me here with a volume unit. So, parentheses 760 times 1,400, close parentheses, divided by 380, gives me 2,800 milliliters. And so if we keep the temperature the same and decrease the pressure, then the volume expands. And this is really easy to see if you think about our container as being a balloon. As we decrease the atmospheric pressure, the balloon will expand. Here expanding from 1,400 to 2,800. As we cut the pressure in half, the volume doubles.